We have a system of force here where we are to calculate for the tension T1 and T2. The question says, what are the tensions T1 and T2 that will keep the 15 kg mass in the system below at equilibrium? A mass of 15 kg is suspended from the wall with the help of a string or with the help of two strings, creating a tension T1 on one of the string and T2 on the other string. If this mass is at equilibrium, find T1 and T2. That is the question. In the first place, what is equilibrium? In physics, equilibrium is a state whereby an object do not accelerate. It means the object is balanced or the object is stable. So if the 15 kg mass is stable, let us calculate the tension T1 and T2. To do this, we have to represent these forces into what we call the force triangle. This is how we are going to form the triangle. In the first place, what is the weight? Because 15 kg is mass, we need to know the equivalent in weight because we are calculating tension, and tension is a force. So we need to calculate the weight, which is also a force of 15 kg. We know that weight is given as mass times acceleration due to gravity, g. If we take 10 to be the approximate value of g, we have that the mass 15 times 10 gives us 150 Newton. So W is 150 Newton, and that is the weight of this mass. So let's form the first triangle. We have a weight acting downward, 150 Newton. Let's write it down. Let's draw that line, 150 Newton, acting downward. Then we have a tension T2 acting at an angle of 50 degrees to the vertical. T2 is acting in this direction at an angle of 50 degrees to the vertical. So if this is treated as a vertical line, which it is, 50 degrees away from it, we create T2. So we have tension T2 in this direction, similar to what we have here, at an angle of 50 degrees to the vertical. So this is force T2. And finally, we close up the triangle. And closing up the triangle, we have the tension T1 acting in this direction, similar to what you can see here in this direction, T1 at an angle of what? 70 degrees to the vertical. So we have 70 degrees to this vertical. So if we trace a vertical line here, T1 makes 70 degrees to this vertical line and in the same direction as shown here. So this is what we call the first triangle. Now that we've obtained this first triangle, or we've drawn it, we can be able to find T1 and T2. But the information is not sufficient, so let's find the different angles within this triangle. If this is 70 degrees, you agree with me that the angle here is also 70 degrees. The reason is because these are alternate angles, and alternate angles are equal. So if this is 70, then this is equally 70. Now looking at this triangle, we know that the sum of angles in a triangle equals 180 degrees. So if this is 70 and this is 50, definitely this will be 60. So that 70 plus 50 plus 60 gives us 180 degrees. Now we have completed the first triangle. Let us calculate T1 and T2. To calculate T1, we are going to use sine rule. Sine rule is simply this. From this triangle, we can say that T1 all over sine 50 degrees is equals to 150 all over sine 60 degrees. This is the sine rule. How did we form this? Simply take one side of the triangle T1 all over the sine of the angle facing it. So we have T1 all over sine 50 because 50 is the angle facing T1 equal to, take another side, 150 all over the angle facing it, 150 all over the sine of the angle facing it. If we take T2, we definitely will do T2 all over sine 70 because 70 is the angle facing it. So this is what sine rules says. Now that we form this, let us solve for T1. By cross multiplication, we have that T1 times sine 60 is T1 sine 60 equal to 150 times sine 50 gives us 150 sine 50 degrees. To obtain T1, we can divide both sides by sine 60 degrees to make T1 subject of formula. So that T1 is equals to 150 sine 50 all over sine 60 degrees. T1 equals to 150 sine 50 all over sine 60. If we put in 150 sine 50 in the calculator, you'll get 114.9. divided by sine 60 is 0.866. If you do this division, T1 will give you 132.6 Newton. So the tension T1 is 132.6. Let's obtain T2 using the same sine formula. So we can say T2 all over sine 70, because T2 has sine 70 facing it, equal to, let's pick 150 all over sine 60. You could also pick T1, which we have obtained as 132.6 all over sine 50, but yeah, any one of them is fine. So to obtain T2, again we cross multiply, so we have T2 sine 60 equals to 150 sine 70. Dividing both sides by sine 60, we have that T2 will be equals to 150 sine 70 divided by sine 60. If you put these values in the calculator, T2 will give you 140.95 divided by 0.866, and this gives us a value of 162.8 Newton. So the tension T2 is 162.8 Newton. You can see that the question is very simple. You just need to understand how to form the first triangle from a given question. Once you can form the first triangle correctly, you can use sine rule to solve. You can use cosine rule if you understand how to use cosine rule, and get the values of the unknown side or unknown angle. I hope you enjoyed this lesson, and I want to thank you for watching this video. Please do well to share this video to others so that they can come to our page and enjoy our content, and that way you keep supporting us. There is a simple one for you at the end of this video, and this is it. If the system of forces shown above, this is above, not below, please. If the system of forces is in equilibrium, find T1 and T2. Find T1 and T2 if this system of forces is in equilibrium. Put your answer in the comment section, and if you have any question, drop it in the comment section. I will be there waiting for you. Once again, thank you for watching, and see you in our next video.